Properties of CiS theta. The main reason for writing complex numbers in polar form is because the properties of CiS theta, which is equal to cos theta plus I sine theta. In questions based on the properties of CiS theta, it is common practice to use the CiS notation for the middle sections, but to return to the cos A plus I sine A notation to finish off. Property 1. Cos A plus I sine A multiplied by cos B plus I sine B is equal to cos A plus B plus I sine A plus B, i.e. CiS A multiplied by CiS B is equal to CiS A plus B. So to summarise, to multiply two CiS's, simply add the angles. Part 1. Show that cos A plus I sine A multiplied by cos B plus I sine B is equal to cos A plus B plus I sine A plus B. So we're basically trying to prove property 1. So cos A plus I sine A multiplied by cos B plus I sine B. So we're going to crack open the first egg, or the first set of brackets, bring down the cos A, stick on the second egg, which is cos B plus I sine B. Then bring down the I sine A, and again stick on the second egg, which is cos B I sine B. Cos A times cos B is cos A cos B. Cos A times I sine B is I cos A sine B. I sine A times cos B is I sine A cos B. And I sine A times I sine B is I squared sine A sine B. In the next step, the only thing that changes is this I squared becomes minus 1 with brackets around it. And in the next step again, the only thing that changes is the sine A sine B at the end has a minus in front of it. At this point, now we can simplify and put the real parts together and the imaginary parts together. So a real part is basically anything without an I stuck on. So cos A cos B and minus sine A sine B. So they're the only two terms with no i's. And then we're going to factorise the I, and inside the brackets put any terms that contain an I. So we're going to have sine A cos B plus cos A sine B. So here's our real part and here's our imaginary part. So now cos A cos B minus sine A sine B becomes cos A plus B. And that's because of our compound angle formula on page 14, which states that cos A plus B is equal to cos A cos B minus sine A sine B. And likewise, sine A cos B plus cos A sine B becomes sine A plus B, because again, our compound angle formula from page 14 tells us that sine A plus B is equal to sine A cos B plus cos A sine B. And we just have our i's stuck onto the front. So we have shown that cos A plus I sine A multiplied by cos B plus I sine B is equal to cos A plus B plus I sine A plus B. So we've just proved property 1. So this is where we got the formulae from in our formula book. So it's a compound angle formula we used. Part 2, hence, evaluate cos 21 degrees plus I sine 21 degrees multiplied by cos 39 degrees plus I sine 39 degrees. So cos 21 degrees plus I sine 21 degrees can be written as CiS 21 degrees. And cos 39 degrees plus I sine 39 degrees can be written as CiS 39 degrees. And this dot here represents multiply. So we know to multiply two CiS's, we simply add the angles. So we're going to say 21 plus 39 is 60. And CiS 60 can be broken down to be cos 60 degrees plus I sine 60 degrees. And cos 60 degrees into our calculator gives us a half. Sine 60 degrees gives us root 3 over 2, and we have an I stuck on. So we used property 1 to work this out. Property 2. 1 divided by cos A plus I sine A is equal to cos A minus I sine A, which equals cos minus A plus I sine minus A. Or 1 over CiS A equals CiS minus A, which equals cos A minus I sine A. So to summarise that, we can invert a CiS by changing the sign of the angle. So to get the inverse of 1 over CiS A, we get rid of the 1 over and we just change the sign of the angle. And a cosine minus I sine can be written as CiS of minus the angle. So a cosine minus I sine can be written as CiS of minus the angle. Example 2. Show that 1 over cos A plus I sine A is equal to cos A minus I sine A, which is equal to cos minus A plus I sine minus A. And part 2, calculate 1 over cos 45 degrees minus I sine 45 degrees. So what we want to do is basically prove property 2. So we have 1 over cos A plus I sine A. So what we're going to do is multiply the numerator and the denominator by the conjugate of the denominator. So basically we just change this plus to a minus. So 1 multiplied by cos A minus I sine A is just cos A minus I sine A. And then cos A by cos A is cos squared A. Cos A by minus I sine A is minus cos A I sine A. And I sine A by cos A is cos A I sine A. And I sine A by minus I sine A is minus I squared sine squared A. Next we simplify. We bring down the cos A minus I sine A, that stays as our numerator. We bring down the cos squared A. The minus cos A I sine A and the plus cos A I sine A will cancel. The minus I squared becomes minus minus 1, and we bring down the sine squared A. Again, the numerator stays the same, cos A minus I sine A. Again, we bring down the cos squared A, and minus minus 1 becomes plus 1, and plus 1 multiplied by sine squared A is just sine squared A. And cos squared A plus sine squared A is 1. We know that that's one of our trigonometric identities from our formula book. So cos A minus I sine A over 1 is just cos A minus I sine A. And cos A will become cos of the angle minus A, because again, from our formula book, cos of minus A is equal to cos A. And minus I sine A will become plus I sine minus A, because sine minus sine A is equal to sine of minus A, again from our formula book. So we have shown that this is equal to this. So this is the page that we got our trigonometric identities from, and it is page 13 of our formulae and tables, and it is trigonometry. So the three highlighted identities here we used in the previous example. Part 2, calculate 1 over cos 45 degrees minus I sine 45 degrees. So this is the long method. So similar to what we did in the last example, we're going to multiply the numerator and the denominator by the conjugate of the denominator. So we basically just change this minus to a plus. So multiplying 1 by cos 45 plus I sine 45, we get cos 45 plus I sine 45. And multiplying cos 45 degrees by cos 45 degrees, we get cos squared 45 degrees. Multiplying cos 45 degrees by positive I sine 45 degrees, and then multiplying minus I sine 45 degrees by positive cos 45 degrees, we'll get the same term, one's positive, one negative, and they cancel. And then multiplying minus I sine 45 degrees by positive I sine 45 degrees, we get minus I squared sine squared 45 degrees. Minus I squared is minus minus 1, and minus minus 1 is plus 1. And 1 multiplied by sine squared 45 degrees is positive sine squared 45 degrees. And we know that cos squared A plus sine squared A is equal to 1. So cos squared 45 plus sine squared 45 is also equal to 1. We know this from our trigonometric identities on page 13 of our formula book. So cos of 45 degrees plus I sine 45 degrees over 1 is cos of 45 degrees plus I sine 45 degrees, which gives us 1 over root 2 plus 1 over root 2 I. Now the same question using the short method. So 1 over cos 45 degrees minus I sine 45 degrees is 1 over CiS minus 45 degrees, which is CiS 45 degrees, which is cos 45 degrees plus I sine 45 degrees, which gives us the same answer. So to invert a CiS, we change the sign of the angle. So to summarise, 1 over CiS positive x will give us CiS minus x, and 1 over CiS minus x will give us CiS positive x. So to invert a CiS, we change the sign of the angle. Property 3. Cos A plus I sine A divided by cos B plus I sine B equals cos A minus B plus I sine A minus B, i.e. CiS A divided by CiS B equals CiS A minus B. So to summarise, to divide one CiS by another, subtract the angle on the bottom from the angle on the top. So property 3 follows immediately from properties 1 and 2. So cos A plus I sine A can be simplified to CiS A, and cos B plus I sine B can be simplified to CiS B. So CiS A divided by CiS B is going to give us CiS A multiplied by CiS of minus B, and this is because CiS B is really 1 over CiS B, and we know that 1 over CiS B is CiS of minus B. So again, from property 2, to invert a CiS, we change the angle. So here we are multiplying two CiSes, so we add the angles. So A plus minus B is A minus B, and CiS of A minus B is really cos of A minus B plus I sine A minus B, which is what we stated at the start. Alternatively, property 3, this property, can be derived directly by multiplying top and bottom by the conjugate of the bottom, cos B minus I sine B, and then tidying up. Example 3. Express cos 5 theta plus I sine 5 theta divided by cos 2 theta plus I sine 2 theta in the form of cos alpha plus I sine alpha. So we're going to use property 3 to help us with this. So cos 5 theta plus I sine 5 theta can be simplified to CiS 5 theta, and cos 2 theta plus I sine 2 theta can be simplified to CiS 2 theta. And CiS 5 theta divided by CiS 2 theta is going to be CiS 5 theta minus 2 theta, because when we're dividing two CiSes, we subtract the angle. 5 minus 2 is 3, so we get CiS 3 theta, which breaks down to be cos 3 theta plus I sine 3 theta. These properties of CiS may be interpreted on the Argand diagram. First of all, if z is equal to CiS theta, which is equal to cos theta plus I sine theta, then the modulus of z is equal to the square root of cos theta squared plus sine theta squared. And cos A squared plus sine A squared gives us 1. So cos theta squared plus sine theta squared also gives us 1. So we get the square root of 1, which is 1. Thus, every CiS has a modulus of 1, and so lies on the unit circle of the Argand diagram. So here's our real axis, here's our imaginary axis, and here we have our unit circle, which has a radius or modulus of 1. Now suppose z is equal to CiS A, which is cos A plus I sine A. So this is z. And w is equal to CiS B, which is cos B plus I sine B. So there's w. And u is equal to z times w. So there's u, which is z times w. And v is equal to 1 over z. So here we have v. So we have z, w, u, and v. U equals z multiplied by w. And z is CiS A, and w is CiS B, so it's going to be CiS A multiplied by CiS B, which is going to be CiS A plus B. Thus, multiplying w by z is a rotation of w about the origin in an anti-clockwise direction through the angle A, which is the angle z. So multiplying the complex number w by the complex number z rotates w about the origin in an anti-clockwise direction through the angle A, which is the angle of z. Now suppose P equals or cos B plus I sine B, which is equal to or CiS B. Then Z times P is going to be CiS A multiplied by or CiS B, which will be or CiS A plus B. This point is the same distance from the origin as P, so this point is Z times P, but has been rotated through an angle of A. Hence, multiplying any complex number by a CiS rotates it about the origin, but leaves the same distance from the origin. So V is equal to 1 over Z, which is 1 over CiS A. And to invert a CiS, we change the sign of the angle, so this gives us CiS of minus A, which is cos A minus I sine A, which is the conjugate of Z. So to get the conjugate, remember we just changed the sign of the imaginary part. So this is the conjugate of Z, because Z was cos A plus I sine A. Thus, taking the reciprocal of a CiS, so 1 over the CiS, has the effect of a reflection in the real axis. So we see here is Z, the complex number, and here is V, its reflection in the real axis. Also, the reciprocal of a CiS is equal to the conjugate of a CiS. U divided by Z is going to be CiS A plus B divided by CiS A. So we worked out already that U is CiS A plus B and that Z is CiS A. So we get CiS A plus B divided by CiS A, which will give CiS A plus B minus A, because to divide two CiS's we subtract the angles. And A minus B will cancel, leaving us with the B. So we get CiS B, which is W. So U divided by Z gives us W. Thus, dividing the complex number U by Z is a rotation of U about the origin through an angle of minus A in an anti-clockwise direction, or an angle A in a clockwise direction. This is true of all complex numbers, no matter what their modulus. If any complex number is divided by a CiS with an angle of A, then it is rotated in a clockwise direction of A, but stays the same distance from the origin, so stays on the unit circle. The properties of CiS may be used to describe how general multiplication and division affects points on an Argand diagram. Multiplication. If Z equals or1 CiS A and W equals or2 CiS B, then Z times W equals or1 CiS A times or2 CiS B, which is or1 CiS 2 CiS A plus B, because to multiply two CiS's we add the angles. Thus, to multiply two complex numbers, multiply the moduli and add the angles. So here's Z, here's W, and here's Z times W. So Z has the angle A, W has the angle B, and Z times W has the angle A plus B. Division. Also, Z divided by W equals or1 CiS A divided by or2 CiS B, which is or1 over or2 CiS A minus B, because to divide two CiS's we subtract the angle. Thus, to divide one complex number by another, divide the moduli and subtract the lower angle from the upper. Two special cases should be noted. Multiplying a complex number by I rotates it through 90 degrees in an anti-clockwise direction. Multiplying a complex number by minus I rotates it through 90 degrees in a clockwise direction. The algebraic operations on complex numbers allow us to move objects around the complex plane, changing their location, their orientation, and their size. This makes complex numbers a very useful tool for programming animation, for example, in animated films and computer games. For example, suppose we have the I object located in position 1 shown. So the I object here, located in position 1. And we want to move it to position 2, which is over here. This involves a translation and a rotation. One way of achieving this, using complex numbers, is to find a transformation, or function f, which will map each point z in the object to the corresponding point f of z in the image. So this is the point z, and this is the point f of z. To find such a transformation, part 1, rotate the object about the origin through an angle A so that the image has the correct orientation, which is basically position 3. So here we have our object I, and what we want to do is rotate it anti-clockwise into position 3. So to do this, Z maps to CiS of AZ. So here we have Z, we rotate it anti-clockwise, and now we have CiS of AZ. Then translate the object from position 3 to position 2 to get f of z. So we translate the object from position 3 to position 2 to get f of z. If this translation is OW, then f of z maps to CiS of AZ plus W, or f of z maps to CiS of AZ plus W. So it was rotated, and then it was moved. And it was moved the same direction and distance as W, but it did not start at the origin, it started at position 3. And it ended up where we wanted it to. So to summarise, property 1, to multiply two CiSes, simply add the angles. Property 2, we can invert a CiS by changing the sign of the angle. A cosine minus I sine can be written as CiS of minus the angle. And property 3, to divide one CiS by another, subtract the angle on the bottom from the angle on the top.